Now let's go on from here. We're in our discussion of electron configurations. We just finished beryllium, and so let us go on with the next question, and that is boron. Okay, boron. Let me check out how many electrons does boron have. Where is boron? Here's boron. It has 5 protons. That means it has 5 electrons. So I need to place 5 electrons, right? So where are we going to start? Well, we're going to start at our 1s, and we're going to put 2 in the 1s. And then after the 1s, we have to go to the 2s, right? And after, how many electrons can I go in my 2s? 2. And then where do we go? Well, let's take a look at our beautiful quantum numbers here. We filled up the 1s right here, right? We went to the 2s, and we have 2 electrons in the 2s, and now we want to go where? To the 2p, right? We have a whole bunch of p's right here. How many p orbitals do I have? I have 1, 2, 3 p orbitals, so I could go 2p. And how many electrons in each orbital? Well, there's 2 here, and 2 possibly here, and 2 possibly here. So I can go as far as 2p6 before I have to move on to my next energy level. Got it? So let's go back here. So I have 1s2, 2s2, 2p1, right? So I have 2, 4, 5. That's right. So this is my electron configuration notation for boron. Got it? Now, did you see what I said about my p's? I said, hey, when I get to the p's, I really don't have one p, do I? I have a px, a py, and a pz. Each of these can hold 2 electrons, right? So when I group these all together and call them just a p, I can go as high as p6. Got it? And that's why I could go up to a 2p6 before I go into my third energy level. All right, here we go. What's next? Neutral nitrogen. Okay, I'm going to let you guys do nitrogen. Are you ready? Pause me, give it a shot. Unpause me when you're ready. Okay, nitrogen. Nitrogen, where are you? Nitrogen has 7 electrons. All right, so let's go back down. Nitrogen, 7 electrons I want to place. Where do I start? 1s2, 2s2, 2p what? Well, let's see. How about 3? Will 2p3 work? Yes, it will. That is nitrogen. 1s2, 2s2, 2p3. Good. Next. A neutral oxygen atom. Okay, I think you guys can do this one too. Are you ready? Here we go. Pause it and see if you can come up with the right answer. Okay, I hope you're back. Oxygen. Oxygen has 8 valence electrons. Okay, that should be a piece of cake, right? 8 valence electrons. 1s2, 2s2, 2p what? 4. Great. Will my p have 4 electrons? P orbitals, it is no chuckling out there. Yes, it will. 4 electrons, sorry. 4 electrons, yes. The p orbital can. The set of p orbitals, right? Px, py, and pz. That means 3 orbitals. That means I can hold 6 electrons, and I'm only trying to place 4. So yes, that is okay. So it's 1s2, 2s2, 2p4 is my electron configuration for oxygen. Next, neutral neon. All right, I think you guys can do it. I'll give you a few seconds. Are you ready? Here we go. Neon. Let's go up to neon, neon, neon. There's neon. Where's neon? Here's neon. Neon has 10 valence electrons. I think we are experts now. Neon, 10 valence electron, or 10 total electrons, right? 10 electrons. Where do I start? 1s2, 2s2, 2p what? 6. That's 10. There we go. Yeah, 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 yeah. Looks like a winner to me. Next, sodium. Oh, cool, sodium. Are you ready for sodium? Okay, here we go. Sodium. Let's find out how many electrons sodium has. It has 11 protons. That means I need to place 11 electrons. Ready? 11 electrons. 1s2, 2s2, 2p7. No, I can't go 2p7, right? 2p6. Now, where does my next electron go? How about 2d? Can it go to 2d? Well, I'm not sure. Let's go back and look at our quantum numbers. Okay, woo. Let's see here. We have our n equals 1 and our n equals 2. And in my 2, I have s orbitals and I have p orbitals. Do I have a d orbital? No d. There's no d orbital, so where do I go next? Okay, we'd go to n equals 3. And when n equals 3, well, what are my L's? L's go from 0 to n minus 1, so that means it would be what? 0, 1, and 2. For my 0, I have 1 orientation, and there are 2 electrons off of that. For my 1, I have 3 orientations, minus 1, 0, plus 1, and there are 2 electrons off of each of these, right? Or 2 electrons can be found in those locations. And then when my L is 2, I have what? Negative 2, negative 1, 0, 1, 2. That means I have 5 orientations, and in each of those orientations, 2 electrons are permitted. And so in total, with my d electrons, I could put a total of 10, excuse me, with my d orbitals, I can put a total of 10 electrons with my d orbitals. So that means I could go as high as, like 5d10 before I would go to the next set of orbitals. Okay, good. So that's giving you a little foreshadowing, folks. Here we go. What comes after my 2p6? Not 2d, but what? 3 what? 3, where do we begin always? 3, 3 what? 3s. Good. 3s. Okay. 3s. 3s. 1. There we go. So that's my sodium. 1s2, 2s2, 2p6, 3s1. Next, I'll let you guys do magnesium and sulfur. Pause me, and when you're done, defrost me. Okay, magnesium. Magnesium is where? 12, and sulfur is 16. Okay, 12 and 16. Magnesium, 12. Sulfur, 16. So magnesium is going to be 1s2, 2s2, 2p6. What comes after 2p6? 3s. And how many? 2. Good. That's magnesium. What about sulfur? 1s2, 2s2, 2p6, 3s. What? I can only go 2 with 3 s's, right? So that's 2, 2, 4, 10, 12. I need 4 more electrons. So it goes where? 3p4. There we go. 1s2, 2s2, 2p6, 3s2, 3p4. Excellent. Okay, let's check out our time. How are we doing? Oh, we got plenty of time. Let's move on to one more, at least one more slide. Here we go. Are you ready? Consider the neutral calcium and vanadium atoms. Write the ground. Okay, calcium and vanadium. We'll take calcium first. Are you ready? Calcium. Here we go. Let's take a look at calcium. Calcium. Okay, here's calcium. Right there, calcium. I have 20 electrons that I want to place. Are you ready? Here we go. Calcium. 20 electrons. Calcium. 1s2, 2s2, 2p6. It's 10, right? 3s2, 3p6. Okay, what comes after 3p6? 3d what? Okay, 10, and what do you say, 3d2? How many of you guys think 3d2? Does that make sense? Let's go back, look at our quantum numbers. We come down here after my 3s's. I would go to my 3p's, and after my 3p's, I would go to my, remember this is S, that's P, that's D. After my 3s's, or 3p's, I'd go into my 3d's, right? Well, one would think that is the case, but in fact, it's wrong. Here's where we have some difficulty. Now let me show you why that is, okay, folks? We've got, let's say this is my nucleus, and it's got 20 pluses in here, okay? Lots of pluses. Now, let's start layering our electrons. Okay, there we go. That's my 1s. That's my shell, and there's 2 electrons there, right? And then my 2s. Here's my 2s. And there are electrons there. Then what kind of orbitals do I have? 2p's, and those are peanuts, right? So here's a 1 2p, and here's 2 2p, and then 3 2p, which is coming straight out at us, but I'll kind of do it like this. But it's really coming straight out at us in the z direction. So those are my 2p's. And then I have my 3s. Now notice, my 3s is farther away than my 2p's. Yeah, that would make sense. My 3s has higher energy. So there's my 3s. Right? And then after my 3s come my 3p's. Okay, here are my 3p's. They're farther out, right? Here's my 3p's. 3p's. So those are my 3p's. Notice they're out farther than my 3s's, right? So my 3p's. And then what should come? My 4d's. Let's go with green. 4d's, right? Double. That's 1 4d. 2 40s, yeah, 3 40s, 4 40s, and then of course we have our donut 4D. Yeah, okay, so that's my 4Ds. And now, not 4Ds, those are my 3Ds. Sorry about that, folks. Those are my 3Ds, right? Because these are my 3S's, my 3P's. Those are my 3Ds. Wow, and it almost looks 3D. But let me show you where my 4S's come. My 4S's come around like this. And what do you know about my 4S? My 4S is closer to the nucleus than my 3Ds. What does that mean? That means my 4S's have less energy than my 3Ds. And according to Aufbau, we want to enter the orbital of lowest energy first. Ach du Liebe. Okay, let's add some stuff to our notes way back here, right? We started these notes and we have some things about relative energies. Now let me give you the absolute energies. The absolute energies. These are energies by shell or by subshell. 1s is less than a 2s. 2s is less than 2p. And then we have 3s, 3p, 4s, 3d, which is less than the 4p, which is less than the 5s, which is less than the 4d, which is less than the less than the 5p, which is less than the 6s, which is less than the, oh my gosh, 4f, which is less than the 5d, which is less than the 6p, which is less than the 7s, which is less than the 5f, which is less than the 6d, which is less than the 7p. Oh my gosh. That is brutal, Mr. Smith. Yes, it is. Ooh. Okay, So let's see. Can we answer our question now? I think we can. I think we can say what? After my 3p6, I would have 4s, what, 20. I need 2, 4, plus 6, 10, 12, 16, 12, 18, 4s2. Okay, so for my magnesium, is it magnesium? No, I don't think so. I think it is calcium. So calcium would be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Got it? So vanadium now. Let's do vanadium, and then I think we're gonna call it a day. Vanadium. Here we go. How many electrons for vanadium? Vanadium. Do. Vanadium has 23. Okay, 23 electrons. Great. 23 electrons. Vanadium. Here we go. 23. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Now what comes next? Hey. Here we go. This is where we can go with our 3ds because our 3ds are closer than our 4p's. So now I go 3d, and how many do I need? 2, 4, 10, 12, 18, 20, 3. So vanadium is 1s2, 2p, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d3. Ouch, I have a headache, and I'm not very happy about this. So we're going to take a break. Now, let me tell you, when you come back, I'm going to make you look like this because I'm going to give you a little secret that'll make everything just perfect. Okay? See ya. Bye bye.